looking at this is combinations. It's different than permutations because, well, first of all, it says a C there instead of a P. Okay, so when we write it out, obviously it looks a little different. This and this should ring a bell. Isn't that exactly what we did last time? And the only thing that's different is now we add in this little piece right here. And so when by dividing, putting that on the bottom, we're dividing our answer by something, that's going to make it smaller, right? And it makes sense because order doesn't matter anymore. And so if I'm picking like Bob and Jim, it doesn't matter if it's Jim then Bob or Bob then Jim. It does not matter what order. So the number for combinations should always be smaller than for permutations. That's why we divide by something extra on this, and it'll always make our number smaller, unless we divide by 1. And then it won't make it smaller, it'll make it the same. That'd be like this. I'm picking one person to be president, and the order matters. Does it really matter then? Because there's no vice president, how do you tell the difference? If we pick one person and it's like Maggie, she's pres. Well, it's not Maggie and then somebody. There's no vice president, it's just president. If there's only picking 1, then there'll be a 1 down here, and therefore dividing by 1 won't make it any different. All right, let's see if you can do that combinations that we just showed you there for a 5 and a 4. I have 5 things taken 4 at a time. That means that there's 4 places for it. Well, you're going to set up 5, C, 4. See if you can figure out that answer. I'll pause it while you finish. So hopefully you knew enough to put the 5 on top. This is 5 factorial over, and then you go 5 minus 4 factorial, which gives you 1 factorial, which is pretty easy. That means just 5 factorial over 1, which means 5 times 4 times 3 times 2 times 1. I bet you can even do that in your head because I told you not to use a calculator. 5 times 4 is what? 20 times 3 is what? 60 times 2 is what? 120. Raise your hand if you had 120. All right, that's not that many people. Did I do something wrong? Oh, what I just did was the what? Permutation. So some of you guys that had that right didn't really have it right. All right, what do you need to have the combination? Yes. That's the new thing, right. This number right here needs to go over here. All right, so it really should have a 4, 3, 2, 1, which then will cancel that. And what's the real right answer? 5. Raise your hand if you had that answer. Okay, good. Now, some of you might have got sucked in by what I was talking to you about before there. All right, let's do one more. I believe in practice, so try this one. 6. No, P's are easy. We did those yesterday. 6C3. C stands for combinations. So that means that this is the kind of problem where order does not matter. It's fraction bar to start with. Good. And then what? 6 factorial over and a 3 factorial. Good. This guy comes over. All right. And then that's really 6 times 5 times 4 times 3 times 2 times 1 over 6 minus 3 is 3 factorial. 3, 2, 1. And the other 3 factorial. 3, 2, 1. Then I can do some canceling. This is an obvious one, right? And then how can I do the other canceling? Make it a lot easier than just trying to multiply them all. Kyle? 3 times 2 is 6, so down here we have a 6, and up there we have a 6. Cancels. Perfect. Final answer is what? 20. Raise your hand if you had that one right. All right, that's more people than last time. Good. All right. That is combinations. Now, combinations are different than permutations. I want to sum it all up for you with this slide right here. Yesterday, we did just permutations where the order matters. Like, for instance, if we have 3 people, that are competing, Sally, Craig, and Dave, they can come in either this way, this way, this way, this way, this way, or this way, and that's 6 different ways. Today it's combinations. That'd be like when I pick Craig, Dave, do I need to write Dave, Craig? No, because the order doesn't matter. Do you see how there'll be less of them then? There's only going to be 3 of them because each one of them would have had to be reversed when we were doing it this way. So combinations are different because there's going to be less of them. These answers are always smaller than these answers because the order doesn't matter. The only time that's not true is when you are only choosing one person, because then the order, even if I say the order matters, it really doesn't, because there's only one person and therefore I can't reverse it with anybody. Okay? So these answers are always smaller. And then the last side-by-side comparison, if I were doing this compared to this, should I circle the same stuff? The only difference is in the denominator here. There's nothing here. There's an extra, that number, which is that number, ends up in the denominator. So that's why when you're dividing by that number, it'll make it smaller. Okay, so that sums up the difference between permutations and combinations. Any things that you want to ask me about those? Okay. Homework for today. All right, so I can stop the tape.